and good morning to all the attendees. I'm going to chat to you about brakes and braking fundamentals this morning. And without further ado, let's get on with it. And we'll be talking about basics of braking, comfort and safety in braking, main components of braking, front brakes, rear brakes, and a bit about brake technology. But before we start, I want to reiterate a little issue that is quite important, that we strongly suggest no copper slip anywhere on brakes ever. It's an old wives' tale or an old farmer's tale to use copper slip on brakes. We recommend that it's never used anywhere near a brake system. Right, so let's carry on. Let's look at the components of the brake system and brake system perform four basic functions: slowing and stopping the vehicle, which we're all obviously familiar with; holding the vehicle at rest, that's your park brake; emergency stopping, and we all know what that means. When you're unable to use any other form, you employ any possible means to stop. Maintaining control of the vehicle, and this is the new technology, the ABS, EBS, EBD, ESC, and HDC, and I'll chat about those toward the end of the session. So let's look at brakes and the basics. Basically, two things rubbing against each other under pressure equals friction. And that's obvious. If you rub your hands together, you get friction. Friction causes heat. Science says that for every action, there's an equal and opposite reaction. So anything moving in one direction has got a force pushing against it, moving in the other direction. Science also says that energy is neither created nor destroyed. It is only ever transferred from one form to another. The types of energy we deal with in a motor vehicle are kinetic energy, heat energy, sound energy, electrical energy, and potential energy. Those are the four main ones, or five main ones, sorry. In braking, we're specifically concerned with kinetic energy, and kinetic energy is measured in joules. And what we do is we look at kinetic energy in the form that the formula is energy equals a half mv squared. Half m is half the mass of the vehicle. V squared is the speed or velocity of the vehicle squared. So the energy of the vehicle is half the total mass times the speed squared. Therefore, a 2-ton vehicle, bakkie in the case of this example, traveling at 120 kilometers an hour in joules, would be calculated as half of 2 tons is 1,000 kilograms. The velocity or speed squared of 120 kilometers an hour in meters per second is 120,000 meters an hour. Divided by 60 gives you 2,000 meters a minute. Divided by 60 gives you 33 meters a second. We square that, we get 1,089 as a figure of meters per second squared. So then we multiply the two together and we get a total of 1,089,000 joules of energy, which is, in your terms, enough to boil 4 liters of water in 11 minutes using a 2,000 watt heater. So 11 minutes to boil 4 liters of water is the equivalent of what you use to stop your vehicle in the 2 or 3 seconds that it takes once you press the brake pedal. By example, and in comparison, a Formula One car of 1,000 kilograms traveling at 240 kilometers an hour is 28 times the amount of joules that needs to be dissipated during the braking. Hence, that's why you see if you do watch Formula One, you see the brakes glowing red hot when they do come into a corner at high speed, because of the amount of energy that vehicle is displacing. Even though it is such a light vehicle, the speed squared accentuates the amount of energy that has to be displaced. So in a nutshell, if you look at another way of looking at this, if you look at your vehicle has a 100 kilowatt motor, and it takes, let's say in the case of a bakkie, 10 seconds to reach 120 kilometers an hour. And you then expect it to stop in 3 seconds. When you press the brake pedal, you are exponentially increasing the amount of joules that has to be converted from speed energy into kinetic energy. So That's essentially the process that takes place when you press the brake pedal, is you convert kinetic energy into heat energy, and that heat energy gets displaced. So braking in itself is a process of managing heat, because what we do is we create heat to transfer from kinetic energy into heat energy. So we have to manage the heat within the brake system. And that's what makes braking such a special technology and special science as in automotive engineering terms. So let's have a look at the brake components now that we've set the scene for how significantly important braking is to us. In the disc brake caliper assembly system, we have the bleeder screw, caliper, the dust boot, piston seal, piston, brake pads, anti-rattle clips, and rotor. That is a complete disc brake caliper assembly system. And all the components that I mentioned there have to work together correctly at the same time. Brakes are not merely the brake pads that you see in the center there. It is all these bits and pieces that are components of the caliper, all have to work together and have to perform a function at the same time for the brakes to be effective. If there's any form of dust, dirt, rust, grunge and grime inside the caliper on any of the surfaces, the brakes will stick, the brakes will squeal, the brakes will not function properly. You'll have vibrations that feel like metal to metal, even though your brake pads are still thick enough. And so I reiterate again, the concern is that everything inside the caliper must be clean and functioning, and where necessary, correctly lubricated. In the drum brake system, you've obviously got the brake shoe, you've got the wheel hub, and you've got the backing plate, and you've got the brake drum. Inside, behind the wheel hub, you have your retaining clips and your return springs and your wheel cylinder. All are, again, components that have to work together. If any of these components are dirty or damaged or not functioning the way they should, you won't have effective braking. So in essence, when changing brakes, when doing a brake job, it's not just sufficient to change the friction material that you see and assume is worn out. All the components need to be checked carefully and replaced where necessary. So without further ado, let's move on a little bit more into a bit more about friction material. In brake friction material, we have approximately 130 chemicals with an average of in friction material of between 22 and 35 of these chemicals in different selections, depending on the type of friction material that the manufacturer is trying to achieve. And in the mix, you have binders, abrasives, performance materials, fillers, and structure in the mix of the compound. And on the right-hand side of the picture, the greenish-looking picture gives you a microscopic view of how those components are all mixed together. And if you had to take a photograph and magnify a piece of cake, for instance, or a biscuit, you'd see a very similar pattern where all the components are mixed together and form a compound similar to brake friction material. So if we look at the surface, what you see below is basically a gray surface with a little bit of undulation across it. On the right-hand side at the bottom, you can see what that surface looks like when you magnify it deeper. And you can see the structure of the material is rough. It looks rough under magnification. And you have places where debris collects. You have places where the material can be at different levels. Now, why do we use so many different materials in the compound, in the structure of a compound of friction material? If one was to make brake friction material purely out of mud, for instance, sand, you'd get good braking, but you'd have a very high abrasion of your brake discs and your brake drums. So the friction material is designed to be able to operate at all different temperatures, under all different pressures, under all different speeds, and under all different loads, and still be able to dissipate the heat that is generated. I'm not going to go into the details of how the heat is generated. Suffice it to say that during brake friction, a tremendous amount of heat is generated during that pressing of the brake pedal. If we look at the brake discs and drums, brake discs look smooth and shiny. Brake drums internally look smooth and shiny. But if we look at cast iron, what we see in cast iron under magnification, and these three pictures across the bottom are in progressive levels of magnification, you'll see that there are pores and there are dips and holes and pockets within the surface of the cast iron. Now, it's within these pockets of the cast iron that the brake friction material that was in the previous slide gets embedded into the cast iron. Now, this is where it's vitally important to understand how brake friction material works. Brake friction material embeds itself into the cast iron so that when you apply the brakes, the friction material, the brake friction material that's embedded into the cast iron bonds with the brake friction material on the brake pad and therefore causes the friction and the stickiness that allows the stopping force to be generated. So I wanted to put this across in visual terms that these are the places where the brake friction material gets bedded into, and I'm going to talk about bedding in a little while. So if we look at the brake rotors, discs, and drums that when you change brake pads and you take the wheels off and you look at your brake discs or your drums, for instance, and you see that they are rough and worn and look uneven, etc. The purpose for skimming or replacing, but let's talk about skimming. The purpose for skimming your brake discs and your brake drums is not so much to get a smooth surface as in the center picture, but more so to remove the old brake friction material in the upper middle picture where you see the colored debris that is embedded into the friction material in the pockets and the pores. So you want to remove that old friction material so that your new friction material has a fresh bed or fresh surface to bed into so that it can create its own mating surface within the friction process. So in context, a flat surface is important, yes, but the real importance of skimming brake discs or replacing brake discs is to get a fresh, clean cast iron surface. The picture on the right-hand side is one that we've been confronted with on more than one occasion, in fact, numerous occasions over the years, where the brake discs have been allowed to run down so thin and the brake pads have been allowed to run so thin that this was actually on the right-hand side a picture of a ventilated disc that has had this brake surface, the braking mating surface of the brake disc has worn off completely. And all that you see there are the ventilation veins inside the brake disc itself. So that brake disc is no longer even a brake disc. It looks more like a fan actually. But yeah, it's one that we see regularly in the industry. So I did talk about the importance of the brake pads being clean, the brake calipers being clean, the brake discs being clean. Now, what I want to point out just here when you're doing a brake job is very often what the practice is to loosen one of these slide pins, flip the caliper open, pull out the old brake pads, push in the new brake pads, flip the caliper closed again, and do up the opposite slide pin, tighten it up again. Guys, ladies, gents, these need to be removed completely and cleaned properly and lubricated with CV grease, not copper slip. These slide pins are the cause of more issues around worn brake pads, squeal, graunching, grinding sounds than anything else. If these slide pins don't move freely, your brake pads will stick, your brake pads will not last, and your brake discs will also be compromised, let alone the fact that your safety and your life is at risk with these slide pins not moving smoothly and freely within the braking system. Furthermore, when replacing brake pads, or brake shoes on a vehicle, it's also important to replace the spring clips that are present in certain styles and makes of calipers. These spring clips are not made for life. They are wear items, and they should be replaced every time you change brake pads or brake shoes. And in many cases, it's not done, leading to caliper rattle, leading to squealing, leading to noises that aren't acceptable, and also adding to the accelerated wear characteristics of the brake friction material themselves. So there are different forms of spring clips. In the top left is a typical fist type caliper retaining clip for the brake pads and keeping the calipers under marginal tension. The bottom left-hand corner, the pictures of the replacement spring clips, retaining clips and return springs for brake drums and shoes. In the center top is a replacement slide pin, and in the center bottom is a typical caliper boot replacement, external boot replacement, and a different form of retaining clip style. And these retaining clips, and I'm not one to give plugs to different companies, but Quick Brake is a company that manufactures these spring clips in kits, retaining clips in kits, and they provide them into the marketplace, and people more often than not, overlook the necessity of these being replaced. So let's move on to brake fluid, also an overlooked issue within our vehicles. And there are essentially four different main types of brake fluid. You've got DOT5 silicon brake fluid. DOT5 silicon brake fluid is never to be used on a road-going motor vehicle for two reasons. Firstly, if you try and bleed silicon brake fluid in your vehicle, you will battle for many, many hours. But the second part is the brake rubbers and seals and hoses within the brake system on the vehicle are not designed to be compatible with silicon brake fluid. So please ensure that you never use DOT5. DOT3 is the older version of brake fluid, a glycol ether brake fluid, and it has a boiling point of 205 degrees Celsius. And then you have DOT4 brake fluid, which is 230 degrees brake fluid. It's a glycol ether or a borate ester material. DOT5 I've spoken about. And then you get what is strangely enough known as DOT5.1. And DOT5.1 is again a glycol ether product, but it has the same temperature characteristics of DOT5.1 or of DOT5 silicon. So don't ever confuse DOT5 with DOT5.1 brake fluid. DOT5.1 brake fluid is compatible to be mixed where necessary and if necessary with DOT3 or DOT4. DOT5.1 brake fluid is specifically intended to be used in newer vehicles with ABS and any of the new technology systems, because it's of the design of the material. The components within the fluid are there to provide lubrication into the system. Brake fluid is hygroscopic. It absorbs water, and it should be changed every 12 months, but do not exceed 24 months as a maximum time before you change brake fluid. And I'll show you on the graph now where Shell did the test on DOT brake fluid, and they tested DOT4, and DOT3 brake fluids here. They tested different ones, and you can see with the ingress of water, which picks up through the ambient temperatures, humidity, the rainfall, etc., that we have in South Africa, we have a very high level of absorption of fluid into the brake fluid. And you can see here that anywhere from 4% onwards, you've more than halved your brake fluid boiling point. And remember, As you get down into the lower reaches, boil water in the brake fluid will boil at 100 degrees Celsius at sea level. The moment water boils, it becomes steam, and steam compresses, causing a loss of brakes. It's as simple as that. Your brake system runs anywhere up to 400 degrees Celsius at times for short spaces of time. So boiling water, having a higher percentage of water in your brake fluid is critical. It will cause a critical failure of braking. So changing brake fluid, maintaining the high level of boiling point is vitally important to your safety and the safety of other road users. And also the brake system remains clean internally. Brake rubbers and brake rubber kits, these are also overlooked in a brake system. These are brake rubbers that are contained here. We see the brake seals, the internal seals of the caliper, the outer rubbers, the dust seals, the brake hoses. We've got braided brake hoses here. These are all designed to last for 5 years. The intention being that in 5 years' time, they will have done their job. They've been through enough heat and cooling. They've been through enough pressure changes. The rubber, especially in the rubber hoses, the pressure that goes into those rubber hoses is relatively high, and they are stretching and compressing, stretching and compressing. They cannot be expected to last forever. And in terms of your own safety and good health, it's worth making sure that they are in a good condition. Going into a bit of brake technology now, if we look at ABS, when you press the brake pedal and with an ABS system, the intention is for it to stop the brakes from locking and to allow you to, instead of ending up in the top left-hand corner picture, going straight ahead because your wheels have locked up and skidding, the intention is to allow the wheels to continue rotating under braking, but so that you have directional control and stability control in and where you need to bypass an obstacle in your path. How these work, they pick up the speed off the wheels. If they feel, if the computer senses, and the computer is sampling it in excess of 20,000 times a second, if the computer senses that one wheel is slowing faster than another or has stopped before another, the center box picture is the ABS controller, and that will then adjust the amount of brake force that goes through to that wheel, either releasing or increasing as necessary to keep the wheels rotating with the greatest amount of retardation that's available. So you have a brake control module on the right-hand side picture. You have a brake control module, you have the master cylinder, and then you have the hydraulic control modulator. And the hydraulic control modulator is the real muscle behind the ABS system. EBD, electronic braking distribution. This is a management of the braking system in terms of, especially with load, how the brake system is managed when there's load in the vehicle. If you look on the right-hand side of the schematic in picture, you'll see light load, and it shows on the right-hand side small rear brakes, and then heavy load, it shows large rear brakes. That's ideally what the EBD does. The EBD makes sure that you have sufficient braking in the rear when fully loaded, as well as in the front, giving you the best stopping distance. And if you look at the picture on the right, the vehicle with a driver only stops in a short distance. The vehicle with passengers with EBD stops in a slightly further longer distance. But a vehicle with passengers without EBD takes twice as long to stop because the brake force is not applied in the same manner as it should be. Electronic stability control. This is around how the brakes are used to allow you to keep on the path that you want to keep on and not understeer or oversteer. Oversteer being when you turn in too tight, understeer when you're going out to the left-hand side. And again, it all combines with the similar functions of ABS and EBD, where the machine or the computer is measuring where wheels are slipping, where wheels are rotating faster than others, and it keeps you under control so that you maintain that control, all managed through the braking system of the vehicle. So again, excuse me. Again, if we look at the situation where if your brake system is not properly managed and maintained, these systems can't work. They just, your EBD, your ESC, your ABS just cannot do what it's supposed to do, irrespective of the complexity of the computer control systems. Hill descent control, I said I'd mention. Hill descent control is obviously for the 4x4 enthusiasts going down the hills. Again, this relies on the brake system of the vehicle to control wheel slippage and to make sure that the wheels are being controlled at a speed that is desirable to the vehicle or to the terrain that it goes down. So again, braking system is crucial to how a hill descent control will work. Brake inspection. A solid brake inspection takes into consideration, first off, brake fluid level. If the brake fluid level has dropped, and then it is a solid indication that the brake pads or brake shoes are worn. If the handbrake lever height is too high, if it's excessively high, the rear brakes need adjusting. Brake pad thickness, too thin means end of life. Brake disc thickness, too thin means it cannot displace the heat and it will cause fade. In other words, the brake disc will overheat and your brakes will fail. Brake hoses and flexibility, too stiff means perishing. Too expansive means broken internally. And too expansive means you hold the pipe in your hand, get someone to press the brake pedal. If it expands more than you think it should, then think about the fact that the internal pipe could be broken. Brake shoes thickness means too thin. Too thin means end of life. Brake drum diameter is exactly the same as the disc. If it's too big, it cannot displace the heat and it can expand to beyond capable torque friction levels. Cylinder leaks will provide loss of pressure. A brake vacuum booster check means that you'll have a hard pedal. Setting the rear brakes correctly to allow for the front to work. If the rear brakes don't work, they can't assist the front, and then you'll have increased rear and wear on your brake pads on the front. And first thing you'll say is that the front brake pads are rubbish. They don't do the job. Meantime, the rear brakes are not doing their side. Bleeding the system correctly. Start at the furthest point from the master cylinder and work through to the closest. Don't try it any other route. You have to start at the furthest corner. So if your master cylinder is on the right-hand side of the engine bay, start at your left rear, move to your right rear, move to your left front, move to your right front eventually. Bedding in the brakes correctly is crucial to supporting your brake system. And we have a simple system there where we refer to the brake bedding at 60 kilometer an hour traveling, reduce braking or reduce speed by braking gently to 10 kilometers an hour. Repeat that 3 to 5 times. Then travel at 60 kilometers an hour for 5 to 10 minutes to allow the brake system to cool again. Then go back to doing another 3 to 5 times of 60 kilometers, slowing to 10 kilometers an hour with gentle braking. Then travel at 100 kilometers an hour for 5 to 10 minutes to allow everything to cool down again. During the process, do not stop anywhere. Do not stop completely at any point in time unless obviously absolutely necessary. You cannot rush this process with higher speeds or harder stops. And repeat, if possible, once all brakes have cooled down completely. So if you can do this little section once, great. If you can do it twice, even better. Your brakes will bed. And if you go back to what I showed you about the surface of brake friction material and the surface of the brake discs or the cast iron, you'll remember I spoke about bedding in. This is to allow the brake friction material, the brake pad or the brake shoe, to put a layer of its own material down into the cast iron to allow it to work. So without further ado, in conclusion, brakes and components have a lifespan. Brakes and components wear. Braking is safety critical. It's life and limb. Budget in the vehicle maintenance plan for regular brake inspection. Inspect every 8,000 kilometers when doing your rotation, balancing, and alignment, as I said in the last session about wheel alignment. Budget for brakes to be replaced roughly every 60 odd thousand kilometers. If they're not lasting that long, you need to make sure that your system's doing what it should. And that's not a guarantee, 60,000. It's just a suggestion. They may last more, they may last less. For the best value, do the job properly every time as well. Please, guys, it's important to do the job properly or have the job done properly by somebody. Don't let shortcuts come into your braking system. Once again, we have lots to talk about with additional sessions in this series. We're going to be talking about batteries and wiper blades at a later date and others. Please tell us what you like to hear. And together we can help put the brakes on your money from flushing down the drain and to help you unblock your profits. From RMI and TIPA, we'd like to thank you for the opportunity to talk to you this morning. I know I've run over a minute or two. I don't know if there are any questions at this stage, Karim, but that's my bundle for this morning so far. Thanks for the time, everybody.